Now we're going to see how to apply the differentiation rules for trigonometric functions in some of these exercises. So let's get started. We have f of x is x squared plus 3 sine x. And again, we want to use what we have learned so far. So before we do this, I'd just like to remember that again, you have a sum of two functions. So the derivative of this f prime x must be first the derivative of the first term x squared plus the derivative of, or you can already apply also the next differentiation rule, which is take out the constant and then the derivative of sine x. Okay, so remember we just used the previous rules that you have learned last week. Now, so f prime x will be first the x squared, the derivative of x squared, that we already know to be 2x. And then plus 3. Now this is the clincher. So what is the derivative of sine x? So could you recall what is the derivative of sine x? Well, if you couldn't, okay, for this class, we can always go back to our list. When we began this class, you know that the derivative of sine x is, so let me just point it out, the derivative of sine x is cosine x. That means that we're going to use that here. The derivative of sine x, sir, is cosine x. And yay, we're finished. Very easy. That must be very easy. You have the derivative is 2x plus 3 cosine x. But what's crucial here is that you were able to apply the rules that you learned for the derivatives of the trigonometric function. Now, let's go to number 7. We have the function cosine x minus secant x. This time you have a difference of two functions. We use again the rule that you have had previously, that is that the derivative of a difference of functions is just the difference of the derivatives of each functions. So that means that we can individually derive the function cosine x and the function secant x and then do the subtraction from there. So now you have the derivative of cosine x minus the derivative of secant x. Now, I know, you're going to say, sir, but we haven't memorized. So yeah, sure, we can go back again to the list that we have had here. The derivative of cosine, remember, cosine. So you have a co there. So surely it must be something negative. True enough, it is. It's the negative of sine x or minus sine x. And the derivative of secant x is secant x times tangent x. So if you're going to do that, implement that here, you will have f prime x is minus sine x minus, okay, and then the derivative of secant x is secant x tangent x. And we're good to go here. Okay, this is enough for me. This is enough for me. Now, I know that you are going to use, I know that you are going to explore applications over the internet that does differentiation for you, and they'll give you final answers already. Many of you will get final answers that wouldn't look like this. And why is that so? It's because your differentiators, whatever you have, most of them will never use trigonometric functions beyond sine, cosine, and tangent. That means that they will have to convert secant here with 1 over cosine. So you might get answers like negative sine x minus tangent x over cosine x. Or you might even get minus sine x minus sine x all over cosine squared x. But these are just the same expressions. These are rather equivalent expressions, and either of them will do as well as final answers. But In our class, we can stick to this. F prime x is equal to negative sine x minus secant x tangent x. No worries, you can stop there. Okay, so just be wary. Just be wary. You might, if you are going to use differentiators across the internet, or if you have downloaded these applications, if you arrive at final answers that doesn't look like what we have in class, most likely because they are using other equivalent expressions that are also equally correct. All right, so we proceed to our last number. Okay, so this one's different, rather different, because you are asked to prove that the differentiation rule that we had. Okay, if you remember, this is the last differentiation rule that was listed at the beginning of this class. It says that the derivative of cotangent x is negative cosecant squared x. Now you are asked to show that this is true. Uh, Before I begin, to be honest, the only differentiation rule that you have to memorize, at least trigonometric function wise, are these two. Okay, the derivative of this of sine of x is cosine x, and the derivative of cosine x is minus sine x. All the other four, you can derive them from these two. So if you don't find memorizing fun, then you can memorize sine and cosine and then move from there. Although it's going to take you time to derive them. And you might arrive at forms that are not the typical ones that you see. Okay? But just to show you that we can derive cotangent x, rather the derivative of cotangent x from these two. So you'll have here, the proof is, so this is the proof. Here goes. Right. Realize or recall that cotangent x is equal to cosine x over sine x. This is a what do you call this? An identity, a trigonometric identity, a basic trigonometric identity that you have from your 10th grade trigonometry. So now that you have a quotient, you can then use the quotient rule. Okay? So, therefore, the derivative of cotangent x is just the derivative of this quotient of functions, cosine x, all over sine x. And because of quotient rule, then we have low d high, so that's low times the derivative of high minus high times the derivative of low all over sine x squared, or low. Neat enough. So you have sine x. Then what is the derivative of cosine x? Sir, I forgot. Okay, we can always go back to the list. Derivative of cosine x is minus sine x. So, sir, that's minus sine x minus the cosine of x. Oops, sorry, sloppy notation. Okay, minus cosine x times, what's the derivative of sine x? Sir, I forgot. Okay, check again. The derivative of sine x is cosine x. So this is cosine x all over sine x squared. Now, so, sir, this is negative sine squared x minus cosine squared x all over sine squared x. Okay? Sir, I think I recall the identity sine squared x plus cosine squared x is 1. So, sir, that means that this is from Trig. So that means, sir, that the numerator now is equal to or let me write. So the derivative of cotangent x to continue is, okay, the numerator can be rewritten now as negative of sine squared x plus cosine squared x all over sine squared x, which is just the negative of 1 all over sine squared x. But sir, 1 over sine x is cosecant x. Correct. That is why finally you have the derivative of cotangent x is negative cosecant squared x. And thus, okay, finishes our proof. So you see, you can derive the derivative of cotangent x just by knowing the derivatives of cosine and sine x. Okay. Of course, it's gonna take you long, so I still um, recommend and suggest to you that you memorize the derivatives of the 6 trigonometric functions instead. All right, but just to show you that we could actually do that also, we can derive from the basic derivatives of cosine and sine x to get to the derivative of the other trigonometric functions. Okay, so that ends our treatment of today's topic. Again, just to be reminded, these are the derivatives of transcendental functions that you know so far. Okay, so if I were you, try to begin memorizing them. They're not really quite tough to memorize. They're quite easy, and you can invent your own mnemonic devices to help you memorize them. All right, so that's it for today. Thank you very much, and see you next time.